another math lesson. This is Mr. Whitford. We're going to be going over adding and subtracting integers from Math 8. So I'm very excited to get started. Let's dive right in. All right. As you guys should be aware, the very first thing that starts with our worksheets, we start our worksheets with Beltwork. So take 5 minutes and see if you could be able to solve this Beltwork. It says, circle all numbers that you consider or think are integers. So circle all numbers that you consider or think are integers. Right? Do you think 0, pi, 3.14, 7, 2/3, -8? Which of these are integers? You can pause this screen right now. I'll give you a few minutes. All right. So I'm hoping that you answered and put in your answer and circled these 3 numbers. Hoping that you circled 0, 7, and F, -8. Okay? These 3 are indeed integers. Now, the other 3 that you have there, they're not integers for the simple definition of what an integer is. Right? Today we're going to be talking about adding and subtracting, and the way we're going to do that is by knowing how to do, using some representations, right? Using something called counters, drawing circles. But I want you to know that we need to know what an integer is in order to make sure we're adding and subtracting them. So an integer is a whole number, right? Such as 0, 7, -8. Numbers that are not fractions or decimals. We're also going to be using some additive inverse. Inverse means opposite. So the opposite of a subtraction is addition. And the way we're going to add and subtract is by doing the opposite. So if it's subtraction, we're going to make sure we use addition. And if it's addition, we can just leave it as addition. Okay? And I'll walk you through exactly what that looks like in a little bit. But for now, what I want you to do is see if you can do this warm-up problem. So I'm going to give you another second to try to dive in to answer these very basic questions. Find the missing numbers. What numbers need to be filled in order for these statements to be true? So -7 plus what number equals 0? And 4 minus what number equals 0? Take a second, pause the video if you need to, and answer that question. What number plus -7 and 4 minus what number will give you 0? All right, so now we take a second to pause and try to do that. I want to reveal the answers. You should have got 7. And you should have got 4. Now, why are these the case? These are additive inverses. -7, the opposite of a -7 is a +7. A +4, the opposite of a +4 is a -4. But Ms. Whitford, that's not a -4, that's just -4. Well, believe it or not, we can rewrite this another way, and we're going to practice that today. So if we want to rewrite this statement as an addition problem, you'll see exactly where the additive inverse is. 4 plus -4 is really what 4 minus 4 is. If we wanted to write it as an addition problem, because the truth value is still there, right? It still equals 0. Unlike if you put 4 plus 4, we know that that's not equal to 0. That can't be the case, okay? So in this case, when we're looking to write the additive inverse, what we really want to do is we want to attach this minus sign to the second number and add a plus sign in front of it. Put parentheses around the second number if you would like, as I did. Okay, this is how we're going to rewrite subtraction problems as addition problems. Let's keep going. Okay, I'm going to model for you what we're expected to learn today. Now, there are 4 problems here. Believe it or not, I'm only going to do 2 problems because 2 of them are actually the same as the other 2. Let me show you. So, looking at letter A of the modeling, it says -7 plus 4. Now, it'll be very easy for me to try to calculate that the way we did on a calculator or something like that. But I want to show you how to do this with counters, with some type of visual representation. Some of you may have learned how to use the number line. I want to show you how to use counters. Let's say, for example, I give you an open circle. An open circle is actually equal to any positive number, or not any positive number, but rather it's going to represent positive numbers. Okay, So if I only have one there, that'll be one positive number. If I put two open circles, that's two positive numbers. This shaded circle, you guessed it, is going to represent negative numbers. It's going to represent negative numbers. So we have positive numbers, negative numbers, and there's one more thing I must let you know. If I take one positive plus one negative, the answer is going to be 0. Now, why is it 0? Similar to what you did above, right here in the warming up, similar to this warming up area, that's exactly what this says. It's an additive inverse. Negative 7 plus 7 equals 0. Open plus close has to equal 0. They're opposites. As inverse means opposites. Our goal then would be to represent these numbers either as positive or negative to see what the answer would actually be. Now, if you know off the top of your head that this answer is -3, great job. However, I want to visually show you how to see that -3. So first thing I'm going to do is start off with this -7. I'm going to draw 7 circles. And because they're negative, I need to remember negative numbers are going to be represented by shading them in. 1, 2, 3, 4, 5, 6, 7. Now, I'm going to shade these in because it's a -7. Okay? The next thing I need to do is to say, I want to then put 4. Now the 4 that I'm going to put is going to be 4 circles. Will they be open or will they be closed? They're going to be open. Why are they open? Because this number is a +4. A +4 means I need to leave these 4 circles open. Okay, so -7, +4. Now remember this key part of the rule. It says 1 open plus 1 closed has to equal 0. So what does that mean? What does that mean in this situation? That means that I can start saying, okay, I have 1 open, 1 closed, cancel. 1 open, 1 closed, cancel. Now, why am I canceling? Because they equal 0. We know anything added to 0 is the anything, right? So we don't need to know those, that they're there. Those zeros are there. And then we say, okay, well, what are we left with? What are we left with now? And you and me both can see that we're left with these wonderful 3 things. So these are 3 circles that we're left with. Now, is this a positive or is it a negative? They're shaded in. So shaded in means negative. So we put negative right there. And we call it a day, just like that. Now, when we look at B, now I want to show you B. Now, if you need a second to write that down, or if you need to rewind the tape, feel free to do that. All right, take your time to really understand what we did in order to receive this answer, not just knowing how to mimic me, because not all the problems are the same as -7 plus 4. They're going to be a little bit different, okay? Let's look at B together. B says -7 minus 4. Now, this could be different. Is there somebody on the phone for me? Oh, in a second. Okay. I'm sorry. That was my wife. I just wanted to see if there's somebody calling. -7 minus 4. What we're going to do is this. I want to actually write this. Instead of being a subtraction problem, I want to write it as an addition problem. But how do we do that, Ms. Orford? I'm going to explain. I want to say, okay, instead of it being a -4, just like we did above here, I'm going to make it plus -4. So it's going to look something like this. -7 plus, parentheses, -4. This is how we turn it from subtraction to addition. Now, why am I doing that? Why to do that, Mr. Wilford? Because I learned that students in 8th grade, 7th grade, you guys are better at addition problems than you are at subtraction. So what, you want to make us weak? No, because in the end, this is still a subtraction problem. However, if you can perceive it better as addition, then let me try to strengthen your understanding in another way. And that's what I'm doing. I'm trying to strengthen your understanding to see, okay, wow, I can use the additive inverse. I can add this number and negate it, and then I'll be able to create the same problem with the same exact answer. It just looks a little bit different. Now, why did I do that? Because now I can use this particular style a lot easier. I can use it a lot quicker, right? Let me show you. We can say, okay, -7. We draw ourselves 7 circles. 7 circles. Then, remember, oh, I'm sorry. Should they be open or should they be closed? They should be closed. Why? Because it's a -7. It's a -7. So I'm going to shade them in and close each one of these. Okay? All right, now I have to add a -4. So I'm going to add -4. 1, 2, 3, 4. Now remember, if you leave this like this, you'll think it's the same exact problem as over there. But it's not, because this is a -4, which means that these 4 should be shaded in as well. Should be shaded in as well. Now that they're shaded in, you actually, can I cancel anything out? No. There's not any open and close here. So I just have to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Boom. That's what I get. Now, is it positive 11? No, because all these numbers were shaded, which means that they were negatives. So you need to make sure you add the negative symbol. Last but not least, now, when we look at C and D, it may seem like, okay, we got 2 more to do. Believe it or not, if you look at C, you'll notice something that's similar to B. You see how I rewrote it as -7 plus -4? Isn't that the same thing that C says? The reason I did that is because I want you to recognize that there's other ways to write these subtraction problems, and you're going to see them quite often. I would prefer you to know how to write it in this form, because if you know how to write it in that form, then you could do the same thing we did in B. Okay, same thing we did in B. Now, for letter D, this should kind of be a reminder to some of you, because you might have seen this before. You might know, oh, I know what I need to do there. I know what I need to do. Some of you guys are probably thinking that. What do we do when we have 2 negatives back to back like this? What do? We end up turning it into a positive, -7 plus 4. Now you can see that there is a similarity between A and D, right? So this is the same as A, okay? And that's it. Now, if you have a question, obviously there's an independent practice you need to do, homework that you need to complete. But if you have a question, I would recommend you re-watching the video, rewind it where you need to, get as much as you can, and feel free to put in questions underneath this in your Google Classroom page, and I'll do my best to get back to you as quick as possible. Thank you guys so much for watching, and I look forward to seeing you guys in class and learning more stuff in the future. Have a great day.